Hello everyone, I'm Dr. Mamta Gautam from ABES Engineering College Ghaziabad. Today I'm going to discuss combustion. What is combustion? When a fuel or combustible substances is burnt and release the heat and light. It is an exothermic chemical reaction. Fuel react with oxygen and it will form the combustible product. Combustible product and release the heat. That is called as combustion. Exothermic chemical reaction leading to the rise in temperature. Now coming to the calculations, some important points for the calculation. Combustion of fuel. Substances always combine in definite proportions. And these proportions are determined by their molecular masses. Suppose we have carbon undergo combustion in presence of oxygen and form the CO2. Proportion means 12 gram carbon required 32 gram of oxygen form the 44 gram of CO2 after combustion. 12 is to 32 is to 44. That is the definite proportions. Next is air contains 21% oxygen by volume and 23% oxygen by mass. Air molar mass is 28.94 gram per mole. It can be used in the calculation. This value can be used in the calculation. 28.94 gram per mole. 22.4 liter of any gas at 0 degree centigrade and 760 mm pressure, that is called as STP, or we can say NTP, has molar mass equal to 1 mole. We can write this type: 1 mole of oxygen, which is equal to 32 gram of oxygen, which is equal to 22.4 liter at STP. Similarly, as 1 mole of CO2, which is equal to 44 gram of CO2, which is equal to 22.4 liter at STP. Next point is minimum oxygen required for the combustion is equal theoretical oxygen required minus oxygen present in the fuel. These are the some important points for the calculation for the combustion. Now coming to the some combustion equations. C plus O2, it will form the CO2. Weight of oxygen needed in grams or kilogram. Volume of oxygen needed for the combustion. Liter or meter cube. As you know all, 1 meter cube is equal 1000 liter. Suppose we have 1 mole of carbon required 1 mole of oxygen for the formation of CO2. So how to write weight of oxygen needed in grams? 12 gram carbon requires 32 gram of oxygen. How much in x gram? 32 divided by 12 into x. This is the calculation for the weight of oxygen needed in grams or kilograms. Now I'm talking about the volume of oxygen needed, or we can say air needed, in liter or meter cube. 1 mole of carbon required 1 mole of oxygen. So how much in x? X into 1. H2 plus half O2, it will form the H2O. According to weight of oxygen needed, 2 gram hydrogen required 16 gram of oxygen. How much in x gram? Then we can write 16 divided by 2 into x. According to volume of oxygen needed, 1 mole of hydrogen is needed, half mole of O2. How much in x? X into 1 by 2. Similarly as methane plus 2O2, it will form the combustible product CO2 plus 2H2. CO2 is the combustible product. According to weight of oxygen needed, same as, and according to volume of oxygen needed. 1 mole of methane required 2 mole of oxygen. How much in x? We can write x into 2 meter cube. C2H4 plus CO2, and it will form the CO2 plus H2O. CO2 plus OH2O. According to volume, 1 mole of ethene required 3 mole of oxygen. So how much in X? X into 3. Now we will solve this sum numerical with the help of these chemical equations. Calculate the weight and volume of air required for the combustion of 3 kg of carbon. Calculate the weight and volume of air required for combustion of 3 kg of carbon. Combustion of carbon C plus O2, it will form the CO2 after combustion. 12 gram carbon required 32 gram of oxygen. So how much in 3? We can write this type: weight of oxygen required for the combustion of 12 gram of carbon is equal to 32 gram. Weight of oxygen required for the combustion of 1 gram of carbon, 32 divided by 12. Weight of oxygen required for the combustion of 3 kg of carbon, and we can write this type: 32 divided by 12 into 3. 8 kg. 8 kg. Weight, calculate the weight. Weight according. Weight of air containing 23% oxygen by weight. As I told you before, required 100 upon 23 into 8, and answer is 38.78 kg. 38.78 kg. Now we will do with the volume. As I told you before, 22.4 liter of any gas at 0 degree centigrade and 760 mm pressure, that is called as STP. Now 32 gram of oxygen occupies 22.4 liter at STP. 32 gram of oxygen occupy 22.4 liter at STP. 8 into 1000 gram oxygen will occupy 22.4 divided by 32 into 32 into 8 into 1000. Now we get the value 5600 liter. That is the 32 gram of oxygen occupy 22.4 liter at STP. According to volume, air contains 21% oxygen. 21% oxygen according to volume. 100 upon 21 into 5600. This is the air contains 21% oxygen by volume. And answer is 26.67 meter cube. Here we have two answers according to weight and according to volume. According to weight, 38.78 kg, and according to volume, 26.67. This is the volume of air required for the combustion. Now coming to the second numerical, calculate the minimum weight of air required for complete combustion of 1 kg of fuel containing carbon 90%, hydrogen 3.5%, oxygen 3%, sulfur 0.5%, water 1%, nitrogen 0.5%, and ash rest. Remaining amount is ash. Ash is the residue. Water, nitrogen, and ash. These are the non-combustible substance. Non-combustible substance. We cannot use in this numerical. 1 kg of coal contains carbon 90%. We have to convert into grams. How to convert this? 90 into 1000 divided by 100. 900 gram carbon. Similarly as hydrogen, 3.5 into 1000 divided by 100, that is 35. Oxygen, 3 into 1000 divided by 100, and we will get the 30 gram. 1 kg of coal contains. Now we will do the according to weight. Minimum weight of oxygen required for complete combustion of 1 kg of fuel. Minimum weight of oxygen required for complete combustion of 1 kg of fuel. 32 divided by 12 into weight of carbon plus 16 divided by 2 into weight of hydrogen. 32 divided by 32 into weight of sulfur. Weight of sulfur minus weight of oxygen. Weight of oxygen. Sulfur 0.5, it means 5 gram. Now put the value in this formula. 32 divided by 12 into 900 plus 16 divided by 2 into 35 plus 32 divided by 32 into 5 minus 30. And we will get the 2665 gram. 2655 gram. We have to report answer in weight. According to weight, minimum quantity of air required 100 upon 23 into 2655, and answer is 11.5 kg. This is the answer for this numerical. Now we will solve the next numerical. Calculate the volume of air required for complete combustion of 1 meter cube of gaseous fuel having the composition CO 46%, hydrogen 4%, methane 10%, ethylene 2%, nitrogen 1%, and remaining being CO2. Nitrogen is a non-combustible. Not used in this numerical. One meter cube of gaseous fuel contain CO 46%. CO 46% in 1 meter cube. We can write this type 46 into 1 upon 100. 0.46 meter cube. Hydrogen 4%. 4 into 1 meter cube divided by 100. Point 0.004 meter cube. Methane CH4 10%. 1 into 10 divided by 100, 0.1 meter cube. Similarly as C2H4 2%, 1 into 2 divided by 100, which is equal to 0.02 meter cube. And combustion reaction is CO plus half O2. It will give CO2. And second reaction is hydrogen H2 plus half O2. It will give H2O. Methane CH4 plus 2O2. It will give CO2 plus 2H2O. C2H4 ethylene plus 3O2. As I told you before, we have already discussed, and it will give 2 CO2 plus 2H2O. These are the combustible reactions. Now we can write the volume of air needed. How much air needed in meter cube? You can see here 1 mole of CO required half mole of oxygen. 0.46 into 1 by 2. In meter cube, 0.23. Now second reaction is methane. 1 mole of methane require 2 mole of oxygen. 0.1, 0.1 into 2. 0.46 into 1 by 2, 0.23 meter cube. And this is the methane, 0.20 meter cube. Similarly as H2, 0.1 into 2, 1 by 2. And answer is 0.02. Ethylene, 0.02 into 3 mole of oxygen required. And answer is 0.06. Now, total volume of oxygen needed for the combustion of 1 meter cube gaseous fuel, 0.23 plus 0.20 plus 0.02 plus 0.06 meter cube. 0.51 meter cube. Volume of air required for the complete combustion of 1 meter cube gaseous fuel 100 upon 21 into 0.51 meter cube. And answer is 2.43 meter cube. These are the references. Thank you all.